You'll see how it also generates a preview to show you the packing. And in this case, here is the preview showing. So that's the one in orange is the one I selected, and these are the ones that are being repeated. And if I'm happy with this kind of packing, I just press enter. What it does is going to deform each one of these modules in between each corresponding cells on the two bounding cells, the bottom and the top one. And depending on the density of your grid, you'll see that it can take a little time to generate. Mostly, I mean, the deformation happened. It was taking the longest time to generate the meshes and the rendering because I was in a shaded view. So if you want a quick result, you can switch to wireframe. But here, the result is showing now, and you'll see how these modules are being populated, but that wasn't the kind of intent I had. I had it like going on the diagonal. So these triangles need to kind of the base of it to be parallel to the U direction or the X direction, if you will. So I know quickly that this is not the kind of thing I'm looking for. I'll just undo that. So before I actually populate the grid, I need to kind of rotate it pretty much. And there is a routine here in the grid utility that convert, it's the last option here, to convert your grid to a diamond direction. And you can choose it to select your grid, and then really did that to us. Let's just do it again to the bottom grid. And to prove that this is diagonal and in the direction that we're looking for, I'm going to really run a very quick test using 3D grids, space, two bounding grids. And you see how the result is looking. Now it's going to update in a second. It's going to look in the diagonal direction, which is the kind of directionality that I'm looking for. So I'll quickly undo. And what I'll do next is now I'm more comfortable with populating my module now in between these grids. Oh, but as we saw in the example, that I wanted to create a variation. I didn't want to create that, use that uniform module and say, okay, that's going to be the one that I'm going to distribute evenly in between the grids. I wanted to have like a number of variations. Say, for example, this one, that one, and I wanted these three to kind of, let me delete those. Let's say I want these three to randomly kind of populate in between the two grids. And in this case, that will create the kind of randomness that I'm looking for. So let's go back to my two grids, and let's see how can we do that. There is the third level of customization on 3D grids that will actually create the custom 3D variable. If you select that, it will ask you for the first bounding grid, the second bounding grid, and then it will ask you what kind of pattern method you want. There are a few options. If you have some mean surfaces, mean curves, and mean meshes, for example, if you are generating variation between two meshes variations. In this case, I have a list. I have a list of 3 modules, and I want to distribute it randomly. So under the distribution method, I'm going to create or select the random distribution. Group it, and then now we're happy with the options. Now it asks me to select my modules. So I selected my first module. I select my second module. I select my third module. Press enter when done. So it just allows you to select any number of modules in your list. And we told it to distribute randomly. So it will take that list and try to fit in between the grids. But let's see what happened here. So these two grids, let me just try to create a custom using, let me see if I chose the right second. And then the two bounding surfaces. I had some kind of result that is not desirable, so I must have some of the setting that wasn't. So the base 0, random, okay. And that's the first module. Bounding objects, second module. Bounding object. And now we're waiting for the result. And as I mentioned, yeah, so now it's working in the way I selected the grids, or in the way I selected the modules. I skipped one module, so that was the reason for the first result. But you'll see how that selecting multiple modules generated that kind of random kind of effect. If you look at the result now, it's going to update in your screen in a second. Yeah. So now you'll see how that has been populated in between your two grids to create this 3D effect of my modules. Now, if I show the frame, you'll see that there is much of the modules that I didn't really need, and I could have trimmed my grid before populating it with the modules to be able to minimize all these extra modules that I got. But I mean, obviously you can delete those, but you could basically trim the grid before you populate the module. I just want to show you that once you have created your modules, you can select them and Boolean union. I'm just going to Boolean union just part of it. Here you go. So that became only one part. If you want it to also be part of the frame, you can select that with the frame and Boolean union with it. And this way you just create one piece that will be can be 3D printed together. That's basically how you can work with custom 3D paneling using paneling.